This is Nishant with JavaScript Static Security Analysis made easy with JSPrime. Let's give him a hand.
Thanks, Jack, for introducing me. Thank you guys for coming in. I know it's tough to be in a session right after the lunch in the afternoon, so I'll try my best to keep you awake during the session. Okay, so yeah, as Jack mentioned, this talk will be titled as JavaScript Static Security Analysis made easy with a tool that we have been working since last couple of months called JSPrime. And so before we get started, I just wanted to ask you guys, please raise up your hands. How many of you are JavaScript developers here or are involved in source code reviews of secure code reviews of JavaScript? Okay, lots of hands, thank you. Okay, so let's get started. So by the way, this talk will be was jointly prepared by me and my friend Sarthi. Unfortunately, he is not here due to some visa problem, so I'll be taking this session alone. So we have the agenda for today. For the next 45 minutes or so, I'll be speaking on some of these things. We'll first talk about the problem that we're trying to solve, and we'll try to introduce you why it's a problem, what is the problem, and how it can be a problem, and some of the demos. Then we'll introduce the tool or the solution that we're working called JSPrime. I'll tell you what is it, who is it meant for, how it works, what it can do, and what it cannot do, so that I set the expectation right. And though I have kept the last 10 minutes for question and answers, but please feel free to stop me anywhere when you want some clarification or you have some doubts. Okay, so a brief, shameless self-promotion. So I'm first time BlackHat speaker and first time in Vegas too. So a little bit nervous. Hope you'll hope you guys will make me comfortable. And I work as a senior Patnaik at Yahoo, India. And as a, how many of you are from Yahoo here? Okay, lots of guys. So I'm already comfortable. I was previously worked for eBay as a security engineer. During my weekends, so since my manager is here, so I'll just say in my weekends I'm a bug bounty hunter. I have managed to be successful in for hunting some bugs for Facebook, Mozilla, Nokia, Foursquare, and like some similar companies. I was a speaker at NullCon 2012, which is a security conference that takes place in India. And there we release a very basic Firefox add-on that helps you scan for DOM-based XSS issues. I've been studying, self-studying security for last 5 years or so. I occasionally play grand piano and keyboards, and recently I've been turned into a sports bike enthusiast. So that's in my introduction. I'll just take a few minutes to introduce Sarthi. Unfortunately, he's not here, as I told you. He's a very experienced application developer, almost about more than 7 years of experience. He was with Yahoo for the last 5 years or so. He is now the full-time developer for this tool called JSPrime. You can catch him up at his Twitter handle and as well as on Facebook. Okay, so let's get serious. JavaScript. It's nothing new. We all know JavaScript. You guys have been writing applications in JavaScript, but the fact today is that it's the lingua franca of web and mobile now. You see there are new technologies coming up. Firefox OS, you name it, on mobile devices, on mainstream web applications, in hybrid mobile applications like using frameworks like PhoneGap, and in Windows mobile phones, what they call it as WinJS. And there are new SDKs or frameworks being released like the Goo engine, which is lets you write interactive and 3D games using JavaScript and HTML5. So it's everywhere. And sorry, I forgot to mention about Node.js, the new server-side JavaScript. So it's almost everywhere, be it client-side, be it server-side, be it on mobile phones. It's everywhere. So it's becoming the most, the de facto language for developers, because they need to know just one language and they can program for, like, say, whatever application they need to or feel like. So that's about it. And so what is the problem with JavaScript then? So before I talk about the problem in context to security, I just wanted to let you know that why it's a big deal or big deal to review JavaScript based source codes. Why there is a talk on a tool that just scans JavaScript source code and figures out security issues. That's because JavaScript is a very dynamic language. And these are some of the points that I have mentioned. I'll just go through. I'll just go through each one of them and show you some code snippets. And I hope I'll be able to convince you why it can be really a pain, or it can be really tricky to write at least a good JavaScript source code kernel, if not perfect. So JavaScript, as you know, is a object-oriented language. You can create properties on demand. So let us just go and I'll just show you some source codes. Okay, so let me just try and explain you briefly object-oriented and properties created on demand. So you see here, this line separates three different code snippets. But the interesting thing here is all these code snippets do the exact same thing. So what I've done here is I'm trying to create an object called BlackHat, and there's an function called upcoming, which is declared this way, and it has another attribute called events, which is an array. So this is one way you can create an object. This is the second way. I'm using the new operator and defining an object which called BlackHat, and I am using the object.define property to do this exact same thing. Have an attribute called upcoming, which is a function, and passing these function arguments, which is like writable, is it modifiable or not, enumerable, whether it shows up in the foreign loop or the object.keys, configurable or not, whether you can dynamically delete this attribute, and the same thing for the second property called or attribute called events, which is again an array. And this is the third way. I'm doing it via the setter and getter. So next thing is prototype based inheritance. I'll just again go to the same thing. In JavaScript, function is also a class. So there is no independent or specific operator or keyword called, say, like what you do in Java or something, like for defining a class. You can just define a function and that becomes a class. And here the class is a person, and say hello is a new method that I'm creating in the class using the prototype. Similarly, there are functions. In JavaScript, function is a first class citizen. Now what that means is it can be assigned to a variable, it can be an object's property, it can be passed to another function as an argument, it can be returned by a function, it's a class by default, and it can be anonymous. So here you see there are multiple function definitions, all doing the same thing, taking two arguments x and y and returning the multiplication of x and y. In the first case, the function is defined with a function constructor. This is a regular function definition called multiply, and this is a function expression that is assigned to a literal called multiply and using an anonymous function. Similarly, there is something called interesting thing about in JavaScript called closure. Closure is nothing but in one line you can define closure as a nested function. So the outer function, so you have function within function. So you have the outer function within the inner function, together they make up a closure. The inner function can only be accessed by statements within the outer function, and the inner function can access arguments and variables of the outer function, but the vice versa is not possible. So any variables within the inner function is not accessible. So here you see a very simple closure. It just takes two arguments x and y and returns this sum. So here is the outer function called outside, takes the argument x, and this is the inner function inside, which takes the inner argument y and returns x plus y. The outer functions return this inner function, so which makes a closure. So the ways you can call this or do this statement is you can call the outer function with the variable for argument for the outer function, and then you can, whatever it returns, that is this inside the inner function, they can pass an argument to it and it returns 8, in this case 3 plus 5 8. You can also do it as like this. You can take this outer function and pass two arguments separately. It also returns 8. Okay, so coming back, so what I wanted to tell you here is that you can see that we are just doing one simple stuff, and there were like multiple ways of doing it. Some bit easy, or some simple, and some are really complex. So how do you make a static analyzer that is able to handle all these cases really well and can figure out issues with minimum, and the most important thing is with less false positives and false negatives. So that is why I think we have a session here today we will be talking about why it's a pain to write a JavaScript static analyzer. Okay, now coming back to security as the context and JavaScript. In my experience, what I have found, like when I in my free time when I hunt for bug bounties, I figured out that there are many Fortune 500 companies who are very well protected. They have really good server-side libraries that filter against regular cross-site scripting attacks. Now, when I say regular, I mean reflected XSS and stored XSS. But it's very surprising to see that DOM-based XSS is one such variant of cross-site scripting that is present, or it's very common. You find it on almost every such sites. And this is due to the fact that JavaScript is responsible. It happens in the client side and due to insecure JavaScript programming. So that's a problem that we will be trying to solve or figure out how we can solve it. And when you are writing applications in Node.js, it's very much possible to inject JavaScript and run it in context of in the server side. It's pretty much similar to local file inclusion or remote code execution on the server. Okay. So as I told you, server-side filtering fails for DOM-based XSS. That I hope you all know. And JavaScript code review is intimidating, if you know what I mean. So how many of you, I just wanted to ask once again the question, how many of you are involved in reviewing, security reviewing of JavaScript source codes? Okay, so would anybody mind telling me how do you do it? Do you do it manually, or do you use some tools like open source or commercial tools? Tools? Any would you like to name a few tools? Sorry? JSLint, okay. Hailstorm? Okay. 45? Okay. And what is your satisfaction level? I mean, how these tools perform? Are they really good? Are they like, how did they handle false positives, false negatives? Fair? Okay. And the reason I ask this question is because there is the availability of so much libraries, and when we scan JavaScript source code for sourcing pairs, there are libraries like jQuery, YUI, where you have some library dependent source and sinks as compared to the pure JavaScript based programs. So it's really tricky to maintain a track of all these libraries and figure out what is the source and sink pair for each and every library. Well, as I said, I didn't have access to enough JavaScript source code scanners, so that's the reason I asked this question to you guys. Okay. So what is the impact of DOM-based XSS or server-side script injection? I think the impact is almost same when you have server-side, DOM-based XSS. It's whether it's reflected or not, the impact is same. Script injection on server-side and in mobile applications can be really lethal because it runs, it actually enables remote code execution in context to that application. And just imagine about these libraries or frameworks, platforms like Node.js, Firefox OS, Windows 8 applications. So I'd just like to show you some of these vulnerable sample codes before we can, so that I can give you some context before we can move on to what is JSPrime and what it can do or not. Okay. So this is a pretty simple example that I have of vulnerable code that I have written using YUI. So what it does, it simply, tracks the on key up event of this text box and just displays whatever you type. As simple as that. Now, in this case, if you do something like this, so you have an XSS, and this is a DOM-based XSS, and this is the client-side script responsible for causing this XSS. This one is using YUI. I have another one. Using jQuery. This is also the same example. But in this case, it's using jQuery. So these are some sample codes are vulnerable to DOM-based XSS, insecure JavaScript programming. And let me go ahead and show you one vulnerable Node.js application that I have written using JavaScript. Sorry. Okay. So it's 1991. So it's a pretty basic Node.js application. What it does, it's just it has three functionalities. You can pass a JSON object, and you can save this, create a profile with the name, age, gender, location. You can view this profile. What it does, it takes this JSON object and writes a file on the disk, and then reads it back to you. So we can delete the profile. But interestingly, if you go and look here, this code is using eval. So that means I can pass JavaScript statements as an argument and see whether we can create a, just to save time, I have just created the payload. What I'll do is we'll just go ahead and save it once again, and So if you see here, with my payload, I was able to run this command called ls and was able to list the directory on the server. So similarly, I can run commands in the context of the server and create an arbitrary code execution condition. So what we saw here is, one second. So what we saw here was 3 different examples using 3 different libraries as a platforms like YUI, jQuery, and Node.js, and how they can be vulnerable due to insecure JavaScript coding practices like turning, enabling DOM-based XSS, server-side code execution. So these are the problems that we have to solve in context to security. So let me introduce here JSPrime. So what is JSPrime? It's a pretty lightweight source code scanner for identifying security issues using static analysis. It's a tool written in JavaScript to analyze JavaScript. And it uses the open source JavaScript parser, ECMAScript parser called JSPrime. And who is it meant for? JSPrime is, from the day we started working on this project, we were sure of one thing. We were actually focused towards making this tool developer centric so that they can use this tool while writing their code. It can be also used by security reviewers or code reviewers as a first pass in identifying security issues in JavaScript code. And security professionals also may find it useful during their penetration testing engagements. But some of the niche functionalities or features that helps you identify issues on the fly that security professionals might require may not be present in this version. But in this version it's more focused towards developers. So before I go ahead and give you a demo of the tool, I just wanted to briefly run you through and give you an overall idea about how this works. So as I said, we are using the open source JavaScript parser called JSPrime to generate the AST, or the abstract syntax table. Now I'll just go ahead and give you a demo of how this JSPrime AST look like. So how many of you are familiar with JSPrime? Okay. So JSPrime is a very pretty interesting JavaScript parser. It's written by a guy called Arya Hidayat. And it's written in JavaScript, so you can use it, run it in the browser, as well as it has a port of Node.js, so you can run it on the server side. So it has a very basic, so this is a online demo of this parser. So you see a very simple one-line statement. We have a variable called answer, and it's assigned the multiplication of 6 and 8. And the abstract syntax tree that JSPrime generates looks something like this. So what it does, it abstracts all these tricky coding style of developers and just represents a JSON object of the code, and it has a very parsable JSON object, so that we can actually pick up like what are the variable declarators, variable names, and the expressions happening. So what we do is we take this JSON object and it also returns the line number and column number, so that if you want to do some syntax highlighting stuff. And it's being used by some popular in-browser JavaScript IDEs. One of my most favorite is the Cloud9 JS IDE. They also use this parser. So we didn't try to write our own parser because we know that it's very tough. You can just select this option to see the line number and column number of the particular statements. Okay, so that was JSPrime. Now what we do with it? Once we take the JavaScript snippet or the code snippet, code block, we feed it to JSPrime and we generate the AST, the JSON object that I just showed you. We then parse the JSON AST to locate all sources. I'm sure all of you are aware of these sources and sinks in context to JavaScript DOM accesses. So I'll just give a small introduction to sources. So any DOM APIs or any APIs in JavaScript that actually takes data that can be manipulated by the user, or that takes user data, we call it as sources. So that's how the accesses can arise. So if you call those APIs, you can actually take user data. For example, one of the most common example is the location.hash object. So it takes anything after the URL fragment, the hash. So that part is modifiable by the user. The user can tamper with it, and that's what we call it as source. So we locate all such. So I'll show you a list of sources and sinks that we have that we are using. So it takes all the sources, including parsing within the objects that are defined within the code blocks, and prototype based assignments, and keeping track of their scopes. So we know, so this is a scope aware analysis. So we track the scope of these objects or the APIs or the statements, and for our next steps. Then thirdly, what we do is we parse the AST to locate all assignment operations. So for example, there might be code snippets where direct assignment from source to sink is not happening. What they are doing is they are taking an intermediary step where the DOM API is assigned to another variable, third-party variable, and that variable goes to sink. So we all keep track of those assignments as well. Also keeping track of the scopes. We then parse the AST again to locate all sinks and sink aliases. Now when I say sink, sinks are those functions or assignments which make this code execution possible. For example, one of the most common sink is eval. Now if you pass anything to eval, and that anything is user controllable, that can cause code execution. Now there might be cases where user input is not being directly passed to eval, but we have created an alias for eval. So for example, say x is equal to eval. Now we are passing something into x. Now x is not eval. I mean, if you read it in the code, x is not eval, but in runtime x is eval. So we track all, again keeping their scope, keeping a track of their scope. Then we move on and find or locate functions, including closures, anonymous functions, which are fed with sources as arguments. We find functions where sources has been passed as an arguments, and while keeping track of the return values. If the function is returning something, we keep track, whether it's returning the source as it is, or it's returning the function, whatever it's returning, we keep a track. Now once we have collected, so all these data structures are there with us, all these information or metadata are with us. What we then do is we see if any filter functions are applied on these sources, or directly over the sources, or when or before the source is being passed to the sinks. Now when I say filter functions are nothing but functions that are written or that are called to avoid excesses or avoid such security issues. For example, like say filter function, you write a function that actually removes or strips out all those special characters that can cause excesses. So some libraries do offer such filter functions natively. One is with YUI we have the escape object, escape class, where we have the HTML escape.html, which actually filters out all meta characters that can be dangerous in context to HTML. Similarly, the encode URI component, decode URI component, encode URI component can be treated as a filter function when you're actually passing sources in context to URL. So for example, we are setting it to an iframes source. So in that context, if you are actually passing something like the JavaScript : alert document.cookie, in that case, if you apply encode URI component, in that case, it will not be a issue anymore. So we keep track of those filter functions, and I'll tell you how this how we feed these filter functions. You can pass your own custom filter functions as well. Now once we have done up to this, what we do is we do the same process, all these steps, in the backward direction. So first we did it in a top-down direction, then we move backwards in a bottom-up approach, so that we want to just be double sure that we reach the exact source if we start from the sink again, so that just to avoid false positives. And then once we confirm that this particular data flow or this particular control flow is actually is responsible or will create a XSS condition, we then report them by collecting the line numbers. In this version, we are not actually reporting the column numbers of the lines. We are not just highlighting the variable names or the sinks, but we are just reporting the line numbers altogether. Okay, so these are some of the color codes that we are using in the report. So we have an orange color. So I'll just give you a demo, so this will make more sense then. But just for a heads up, that the orange color is an active source. So if we figure out that there is a source which is reaching a sink, and it is making up a pair for creating an XSS or a code execution, we mark that source line as in orange color. And if it is a source but it is unused, I mean it could not reach a sink, we color it as brown. And if it is a source and it has been assigned to some other variables which are not again used, we mark them as gray. Active source assignments, for example, we have a location.hash which is reaching to eval via a third step, say x is equal to, there is a third intermediary assignment. We mark them as in yellow color, which is an active source assignment. Red is the sink. If we find that there is a source sink pair that's causing a execution, we mark that sink as red. And pink color is for functions that lead to sinks. I mean that are function arguments which actually take the functions which take arguments and pass it to the sinks. We mark them as in pink colors. Okay. So what JSPrime can do? It can follow a code execution order. I'll show you in the demo of these points. It can handle first class functions. I have mentioned it earlier. It can analyze prototype based inheritance. It can understand typecasting. It understands context based filter functions. It has to be manually fed though. You have to manually configure it. It has library aware sources and sinks. So far we are supporting just for YUI and jQuery. It has scope-aware analysis for variables, objects, and functions, so that you have less false positives. It has control flow analysis and data flow analysis. What it cannot do? JSPrime alone cannot detect 100% of the issues, like with any other tool. It cannot learn sources and sinks automatically. You have to provide them if you are using a very custom library. It cannot handle obfuscated JavaScript, like in case of malwares or something. It can't report issues in minified JavaScript unless beautified. So there's a catch here. It can analyze minified JavaScript, but since minified JavaScript is nothing but in one line, so it cannot actually report the issue, because it will report that this line 1 has issue, line 1 has source and sink. So you need to beautify it so that you'll be able to understand the report. And it cannot actually analyze dynamically generated JavaScript using eval. So if you are constructing JavaScript or if you are executing JavaScript statements using eval, so it's not, in this version it's not possible yet. But we are working on it. What about stability and automation? So far we have benchmarked that up to 1500 lines of code this tool can handle in a single scan. It might be able to scan a bit longer JavaScript, but this was the longest JavaScript file we had to test. With us, we do have a Node.js port, so that you can run it on the backend server for large-scale automation. You can pass JavaScript files, JavaScript codes, and it can return you results. You can make it as a web service actually to integrate in your continuous integration environment, in enterprise application environment. And it's actually a lot dependent on JSPrime's robustness, and it can be the first point failure. So we have seen some JavaScript files where JSPrime itself is unable to parse, or it breaks. So in this case, since we are dependent upon the AST that JSPrime generates, we are not able to go further. Okay, so time for demo. What we have here is okay, so this is the web version of JSPrime. This looks something like this. So you have a code editor. You can paste your JavaScript snippets. So if you guys are wondering like how you can scan multiple files, because it's just a code editor, so I'll come to that in a minute. Okay, so you remember the first example that I showed you and that I coded in YUI. So this is the script function. What I'll do is I'll just paste it here and I'll try to run scan.
Maybe you missed a curly brace.
Okay, so you see here, this is how the report looks like. This set HTML is a YUI specific sync. So it was able to analyze this script and just figure out that here we have taken this is again a YUI specific source, which takes so you have a text box, text email, and it takes the value and passes it to the div. So it was able to detect the XSS. I'll just go ahead and show you something like this. So that was a simple example. Let us go ahead here, and I'll just try to paste something like this. So this is a short snippet, but it's kind of a little bit more complicated in the first one. What I've done here is there are two functions. One is called as time message, and the second one is called fire. Now fire, when you call this function, it takes the location.hash and passes it to it has an assignment to call, and call is passed as an argument to time message, which is defined earlier, and this becomes the argument, and it's passed to something called eval. Now this is a pretty simple example of DOM XSS. Now if you see here, it reports the first line, the active source call, and it's the pink color shows the source being passed through a function, and finally the sync, which is eval. Now interesting thing to know, notice in this report here is it is actually following the code execution order. If you look here, though the sync was present in line number 3, it's not reported in line number 3. First line is reported is line number 8 here, which means that it actually followed the code execution order and took the source from here, then it went to time message, which is we are passing argument to time message, and then it reported line number 9, the next line that was executed, and finally it went all the way up to the top and reported the sync. So line number 3 is reported at the end. So now let us modify this source code a little bit. Let us take two arguments here, say ABC, and let us pass call to the as a second argument, and let us pass a string, say 12. You see that it reported the sync, but what it reported here is it's a non-active source. That means the source was not reaching the sync. But if you do a swap of these values, it's again orange. It shows that it's an active source now. It reached the sync. Now what happens if I make call as a string instead of a literal? Again, it was able to identify that call it's not actually greping, but it was able to identify that call is actually a literal, and so it's a string, it's not a literal actually. So let us move on to some more interesting examples, or say test cases. Okay, this one. This is a very typical example of redirects developers do. So we have a function called reload, and there is a variable called redir, which takes the location.hash. So when anything that is after the hash, so if you have a passed an URL, the page will redirect you to that URL. So, and the sync here is set attribute. But the interesting thing to note here is set attribute itself is not a sync. If you pass the variable to set attribute and set the attribute is source, only then it becomes a sync. So in this case, and the element is an iframe. So let me just put it here and run. Okay, so you see the orange color again. So this is the line. It is the source, and it found the sync. But let me just change this to something, say ID, which is not an exploitable issue. So you see here, it's not an active source anymore. No syncs are reported. So I'll just go ahead and okay, so this is the prototype based inheritance that I was talking about. It's also able to analyze this. So we're just so you see here we have a function called template, which is a class, and we are defining a prototype called exec and assigning eval to it, so it becomes an alias. And then we have another attribute called param, which is actually taking the source. We have a new class called clone, which is inherited from this template, from the template class. And we are creating a new instance called xy, and then we are calling xy.exec and passing the param, which is nothing but the source. Yeah, so you see the orange color, and the source is able to pass through, and it was able to track down that it's actually a XSS condition. So this is a bit more complex. So this is an XSS that was caused with document.cookie. I'll just refresh it once more. So there is this variable ck holds the document.cookie, and we have a function called getCookie, which basically reads the cookie values. And there is a cookie called RLO. So this was taken from a live site. We have a portal called rediff.com, which is a very popular portal in India. So they had a XSS which is now fixed. So this is the code responsible for causing that XSS there. And this cookie value is being passed to an inner HTML, which is a sync. Okay, so just okay, you see this is the active source, document.cookie, and if we go down bottom, we see that active sync found, inner HTML, it was assigned. So I have another example to show you that I found during one of my So this was an XSS that I found in PayPal. So I'll just go ahead and now let this scan this code. So yeah, it's able to scan. So the use case here was they were allowing uploading a file name, a file. And that file name field was taken from this value, and it was being passed to inner HTML, which was creating the XSS condition. Okay, so there are more complex test cases, just that we are running out of time. Okay, so that was a brief introduction of how this tool works and how it can follow these JavaScript features. So what is the roadmap for this project? We are working on improving the performance and stability. We are trying to focus on multiple file scanning, Node.js project scanning. Oh, okay, I just forgot to show you one more thing. If we go here. Okay. Okay, so this is the Node.js application that I showed you in the beginning. So this is tool is also able to scan Node.js code, and you see here is that we are taking one of the arguments, URL arguments, and we are passing, and is being passed to eval. So yeah, just to give you a example of how we can scan Node.js code as well, Node.js projects. Okay, and we are also planning to have an IDE plugin for, say, Notepad.js or WebStorm or whatever is your favorite IDE. More library support in addition to YUI and jQuery, and support for string manipulation simulation, and of course your suggestions if you have any. So the summary is, it's an actively work in progress. We have a promising roadmap. So we are committed in making it even more better. It's open source today, so you can just go ahead and check out the code. And we have a Node.js port as well. So I'll just go ahead and show you. Okay, so by default this runs on 127. So here you go. You have something like, say, var is equal to location dot hash, and then you pass it to eval. And so the UI is not that much fancy in the Node.js version, but you get the idea. So you can just take it and make it as a web service and run it as a large scale environment. So just to wrap up, it's there on one more thing. We have github.com/dp Nishant. So here you have JSPrime. You can just download the source code, and yeah, this is what this JSPrime source code looks like. So you can just specify your sources and sinks, right? And you can like mention like sinks with conditional sinks, like whether you have set attribute when you have href or src. And similarly, you can write filter functions like we have for escape HTML and code URI component. Okay, so I just wanted to thank these guys, Arya Hidayat, Paul Thirial, Bishan Singh, and Rafe Baloch. Any questions?